Hello and welcome to Chapter 3, Section 4, Modeling Quadratic Functions. Today, when given any number of points, we're going to find the quadratic regression, model, or function, whatever words they use, using the calculator. Make sure you write down the following steps. These steps are the same as what we did to find a linear regression, but instead of going to linear regression, you're going to quadratic regression. Okay, so make sure you have them written down because I will not give them to you again. If you look in step 5, it says write the regression with a given a, b, and c values if r squared is close to 1. Last time when we were doing linear regressions, we looked at the r value. And if you remember, that's called the correlation coefficient. The correlation coefficient has to be close to 1 to actually represent that type of data. Now we're talking about the r squared value because it's a quadratic regression, and that has to be close to 1, which means it has to be 0.8 or higher, or you cannot use a quadratic regression. So let's go ahead and do a problem. In example 1, it says NASA can create a weightless environment by flying a plane in parabolic paths. The table shows heights h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a quadratic function to approximate the height at which this occurs. Now in this particular problem it says use quadratic regression, find a quadratic function. So that's what we're going to do. So over on the left of your screen, there's your calculator, okay? You're going to hit Control, you're going to go to the home screen, right? You're going to go to a new document. Does it ever want you to save? No. And you'll add a list and spreadsheet. And I'm going to put the data in exactly the way I see it in the table on the right. So I have 10, 15, 20, 25, 30, 35, and 40. I also have 26, 900, 29025, 30, 600, 31625, 32100, 32025, 31400. Alright, so we have all the data. That's step 1. Step 2 says to label the columns, and it doesn't matter what you label them. In this case, I'm going to label them T for time and H for height. You can use X and Y, it does not matter. Now, with number 3, in an empty box, so that's where I am here, right? In an unused column, we're going to press Menu, Statistics, Stat Calculations. Try that again. Menu, Statistics, Stat Calculations, and then Quadratic Regression. Right? We don't want linear regression. That's what you did last time, mx plus b. Now we're doing quadratics. So now we pick our x and our y, so t and h. You hit OK, and there's your information. Now, we have to look at the r squared value. The r squared value right here is at the bottom, is 1. That is 1. So this does absolutely represent a quadratic regression, which means we can use this data, and we are going to write the equation. The equation is actually h equals, and we're going to write down the equation based on the a, b, and c that they give us. The a in this situation, if you look at that for the column D and E, a is negative 11. So we have negative 11 t squared plus our b is 700, so 700 t, and our c is 21,000, so plus 21,000. That's the regression. Now, the next thing you need to be able to do is answer the question. So we're supposed to approximate the height at which this occurs, right? So the time that they give us is 20.8 seconds, which means we're going to have to find h of 20.8, which just means you plug it in. And you're going to plug that into your calculator, right? Plug it in exactly where you see t every single time. You get negative 11 times, so negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. If you put all of that in your calculator exactly the way you see it, you get a number. That number is 30800.96. We can't forget our units. It is in feet. And that's the answer. Now, sometimes you don't know if your data is linear or quadratic or whatever. So there is a way that we can figure that out. And to do that, we look at first differences. okay? We're just taking a difference. If the first differences are all the same, then it's linear. If the second difference is all the same, then it's quadratic. So let me show you what this would look like. All right, let's look at part A. We're finding the differences, and it's the differences in the y values. So to find this difference, we'd find 20.4 minus 19.1. Well, 20.4 minus 19.1, if you put that in your calculator, you get 1.3. Okay, and then we do it again. 19.9 minus 20.4 is negative 0.5. 17.6 minus 19.9 is negative 2.3. And 13.5 minus 17.6 is negative 4.1. Now, if those were all the same, it would be linear. But they're not, so it's not. So we have to keep going. Right, so we're actually going to do it again. Negative 0.5 minus 1.3 is negative 1.8, right, if you were to figure that out. Negative 2.3 minus negative 0.5, right, so you end up adding them, is negative 1.8. Negative 4.1 minus negative 2.3 is negative 1.8. Now these are all the same, so it is quadratic. And because it's quadratic, I know to find the model that represents the function that's quadratic. Okay? And I'm going to do that after I figure out B. So let's go over to B and first figure out, is it linear or quadratic? Well, to do this again, you're going to subtract. So you have negative 1 minus negative 3. Well, negative makes that positive, so negative 1 plus 3, which is 2. 1 minus negative 1. Well, 1 minus a negative makes it plus, so 1 plus 1 is 2. 3 minus 1 is 2. 5 minus 3 is 2. Those are all the same, so this is linear. And then finding the actual regression won't be very difficult. Now, hopefully you write this down before I do this, but it's going to get rid of all the data. So let's go find the regression. All right, so we hit Control Doc. Actually, just start a new document. Every time, just start a new document. Because if you try to put the same letters in, it'll give you the wrong information. So we have 1, 2, 3, 4, 5, 19.1, 20.4, 19.9, 17.6, and 13.5. We have to label our columns. Don't forget to do that. Make sure it's all the way where the A and B are. You go to Menu, Statistics, Stat Calculations, Quadratic Regression, because it said it was quadratic. We've got X and Y. We hit OK, and here's our equation. Now let's look at that R value. That R squared is 1, which means, yes, this is quadratic, which we figured out without having to look at the R squared value. It just gave us a heads up so that we didn't have to go through the entire process and then realize it was wrong. So that means that the equation here would be y equals, A is negative 0.9, x squared, b is 4, so plus 4x, and c is 16, so that's our equation. That's it. All right, and hopefully you remember how to find the linear regression. It's the same thing, but instead of hitting quadratic, you'd hit linear, and when you do that, so you should try that on your own when you get to class, but when you do that, you should get y equals 2t minus 5. Okay, and if you don't, ask for help. All right, that's it. That's modeling quadratic functions. Have a great day.